All right, number 8. We're going to find f of g, g of f, in the domains. So we have two rational functions. F of x is equal to 1 minus x as the numerator all over 3x, my denominator. And then g of x equals 1 in the numerator all over 1 plus 3x in the denominator. Finding domain of f. What makes the bottom 0? If I plug a 0 for x, 3 times 0 will give me 0. So x cannot be equal to 0. And then domain of g, 1 plus 3x cannot be equal to 0. Subtract 1, that gives us 3x cannot be equal to negative 1. Divide by 3, and it gives us x cannot equal to negative 1 over 3. So we have a split. Number line, which would give us a union scenario. Now we will find f of g of x. Start out with f. Got a fraction. 1 minus x, which I'm going to leave blank, all over 3x. In the place of x, I'm going to replace it with g. So it's going to be a fraction 1 over 1 plus 3x. And then the same thing on the bottom, 1 over 1 plus 3x. Okay, so I'll do one more step in terms of simplifying. I'm going to just multiply this 3 on the top, so I'll have one fraction. So this will become 1 minus 1 over 1 plus 3x. Then on the bottom, we just have a 3 over 1 plus 3x. So we have a fraction in the top, and a fraction in the bottom. Again, to solve these, we want to multiply by the common denominator. So there's a denominator and a numerator. It is 1 plus 3x. The denominator in the denominator is 1 plus 3x. It's the same. So that is my common denominator. I'm going to multiply top and bottom by 1 plus 3x. 1 plus 3x. So when I multiply 1 plus 3x times 1, I get the same thing. So I get 1 plus 3x. That is this times 1. When I multiply this times this fraction, the top and the bottom will cancel out, and I'm just left with a minus 1. So this is my numerator has simplified. The plus 1 or the positive 1 and minus 1 will cancel out, so you'll just be left with 3x on the top. On the bottom, when I multiply this times this, the bottom will cancel, and I'll just be left with 3. And then at the end of the day, 3 divided by 3, I'm just left with x. So f of g of x is just equal to x. Linear equation, no restrictions for the domain. However, we did plug in g, so the restriction that I had was x cannot be negative 1/3. So that would be my restriction. In interval notation, that would be negative infinity all the way to the left side of negative 1 over 3. Union 1 over 3 all the way up to the right side to infinity, positive infinity. So this would be our domain. And then we're going to do g of f of x. g of f of x, we start with the g equation this time, which is 1 divided by 1 plus 3 times x. And x will be replaced with the f equation, which is 1 minus x divided by 3x. So I'm going to simplify this bottom, multiply by 3, which is going to cancel out the division by 3 on the bottom. And so this will become 1 over 1 plus, that would just be 1 minus x over x. So common denominator. There's a denominator in the bottom, which is x, not 1 in the top. So my common denominator is going to be 1 times x, which is just x. So I'm going to multiply x on the top and the bottom. 1 times x is just x in the numerator. 1 times x here will just give me x. X times this fraction will cancel out the bottom, and I'll be left with 1 minus x. Now, we have a positive x and negative x. They will cancel each other out. X divided by 1 is just x. So the fact that both of these come out to be x when you plug them in means they are inverses of each other, these two functions. And no restrictions here, but we do have to carry over the restriction from f in the beginning, which is x cannot be equal to 0. And interval-wise, that would be negative infinity to 0, union 0 to infinity. So both equations just turned out to be x. And then domain of f of g, negative infinity to negative 1/3. Negative infinity. Yeah, I left off my negative here. Gotta be careful. To infinity. So it looks like D. And then domain of g of f was negative infinity to 0, 0 to infinity. So A.